So this is a part 2 of a footballer classification. In this model, in this video is useful for the two types of peoples. First, who had watched my part 1 of footballer classification, and the second one, who have a model file like .pth file, h5 file, or a .keras file, desktop file. You can see how we can use that file in a Streamlit, and we can make a web app and deploy that web app. So let's get started. I already download my best model from which I pre-trained in part 1, and this is my Jupyter file. Let me make a structure of the we can say for structure of the directory, folders name. Okay, this first folder, second folder will be the model, and third folder will be the utils. Okay, let me make one main file. Let me open this as in Jupyter. Sorry, not in Jupyter, VSCode. Let me drag this to file in model. Okay, now main.py file. Okay, let me first code the you can say code the entire Streamlit code, then I will explain you line by line. Let me pause the video. So let's get started. This is a Streamlit. You have to first download Streamlit in your you can say in your IDE using pip install Streamlit. Okay, this is a utils. You can utils basically from utils means from utils you can say folder set background fetch set background function. How we are fetching it? We have to first make a util you can say util file. Okay, util.py file. In util.py file we are making one function set background. Basically this function basically set the background of the Streamlit which we are want to use. Suppose I'm using this background for my web app. So this set.background basically help me to set the background of my Streamlit. Okay, and to calling that set background function in a main file, for that we have to create this init.py file. In this init.py file you have to use this from.util means from.py file import set background function. Make sure that you have to use this dot here, otherwise it will throw an error. You have to use this from .util import set background. This make us easy to import the function directly in a main file. Let's see this how easy it is. Just give the folder name and set the fetch this background function, okay, which we have created. Now you know what is the meaning of pill here. Torch basically the you can say the framework which we are using. Now this classifier, same way classifier. This is here classifier is a function. In this classifier, see in this classifier.py, I will explain this whole line. That's why I want to explain you this function. This how we are fetching the functions one by one. Okay, or we can say importing the function. This classifier is a function which we are using for classifying and sending label and score function. And same way we have to create this init.py file, and same way from classifier py file Python file import classifier function, so that this make us easier for importing it in a main file. Just give the folder name and the function which you want to import. Okay, this py.id, this is basically for image base 64. This 2 is for the image. Okay, model or CNN. One more thing, this here, see from model same CNN basically is the architecture of our model, and this init is a file which same way from cnn.pl, just to import it easily. Why I had created this and give well, means externally giving the architecture here. I will explain you. Before that I will explain these two lines. Here this config, basically footballer classification is a heading of the you can say a tab. Okay, set background is a function. Now we are using a set background function where we are just passing the background path. This set.markdown basically use for giving the css of the title or any layout. Okay, or we can say template. Here title css is this, and css for the header is this. Okay, now markdown. Here this is the header in which we are giving class title, which automatically fetch this css, and the football classifier is a title here. Unsafe allow html. For this we have to use true here. Same way for the second line in the Streamlit web app. Now this is set.file uploader, basically is to upload the file in a Streamlit web app. Here this is empty because I don't want to give any name to this uploader. If I like upload image type, it will display at the top of that uploader upload image. But I does not want that thing, so I will just empty place it empty here. And what type of images which I want, I have defined here as a list. Okay, basically file it here is just you can see the image which we upload. Now torch dot load. Okay, this model torch dot load means in Jupyter see in Jupyter file. One thing I want to show you. Let's wait for the minute. See, we are saving the model using torch save. If we save the model like torch dot dict means only the weights, so we have to upload it in a different way. But we are saving like torch dot save, so we have to directly load it. And why I am giving that architecture of the CNN model, because when we save the model using torch dot save, there is a keyword will automatically save CNN at the CNN keyword will save in this bash model.pth file, which define the architecture of the CNN model. If we do not define the CNN during loading time, it will throw an error that unknown keyword is there CNN. So to you can say to block that error, or we can say to overcome that error, we have to externally define what is the architecture of the CNN model. For that I am describing it here. I already explained it what is each and every line. Just copy this. See, just copy this entire thing and make a cnn.py file and paste it in a cnn.py file. Your work is done. Okay, just paste it, and after that just load it here. Load in a main.py file, because so that when we load this model, it will does not throw an error that there is no unknown keyword of CNN. To overcome that error, we have to externally define the architecture of the CNN model. Okay, this is a class names which we have described. If file is not none, means if suppose there is a thing that sometime we click on the upload file, but we does not select any image at that time. Okay, if file is not null, then this we have to convert this in a image.open.file image. It will open the file and convert into a RGBE. Okay, and after that it is a function classifier which give me back prediction and a score. Okay, okay, so let me explain you what is classifier. This is here classifier. Okay, it first detect. I already explain you in the here at testing time what is the use of detect and face. Why I had used this detect.face function in this. Okay, in testing time I've explained you. So it will give me, where is the classifier.py file, say this. So it will give me the expansion of the face, expansion face image file, which is of 24 file. I already explain you each and every line in this function in part 1. Okay, and after that, see, it passes two things. It passes two things. If length of the faces is greater than 2, we are passing this string. If the face is not detected, we are passing no face is detected. So it passing the string when there is multiple images or no face is detected. Okay, if this type thing is happen, we see that pre-processed image is a type of string. It means there is some issue in the image, means there is multiple images there present or no face is detected. So for that, we see the type of the preprocessed image. If it is a string, we throw two things. Preprocessed image means the error, and uh, see, ultimately we have to pass two things: label and score. Okay, in place of label we are passing the error message. In place of score we are passing this string error. Okay, so that it makes so that we can use it, this message we can use to throw to display the error if suppose we upload an image with multiple faces, or suppose we upload an image with no faces there. Okay, so that's the thing. Now if suppose all thing is okay, means no one face is present and multiple faces is not there, we have to convert it in grayscale image. Pre-processing, what we are doing, just converting it in a transfer and normalizing the pixels value for ease of computations. After that, transformation means just uh, using this transformation, applying this transformation. And in squeeze, I already told you, in squeeze basically change C, means add one dimension, means CHW convert changes to BCHW. Okay, and return image here. Means before loading the image to the model, we have to perform all the pre-processing which we have done during training time on the image. Okay, after that, this give me the output. Our torch.argument max output.item basically give me the index value, you can say. After that, using of that index value, we can give fetch the label. Okay, after that, using the after fetching the label, how we have to calculate the score. For calculating the score, I already told you that uh, at the CNN level, there's three. The last layer, last function contain 3 neurons, and after using a softmax, it convert the uh, values in the probabilities. Means suppose 3 labels is here. In one first let assume it's 98. In second index it may be 25. Its third index may be 58. Okay, in this way at the end it will give me the give me the array of the probabilities of that particular index values, and index values define as the class name of the image. Okay, so to fetch the score, uh, score of the we can say score of the image, or we can say probability of the image, we have to use output.0. Okay, output.0 here, output.0 define that it is one for the one image, for the first image only. Okay, because we are passing only one image, we are not passing the batch of the images, we are passing just one image. For that we have to get the data of the first image, just iterate to means we have to use 0 here. After that, on a prid, here prid basically give me the index value, maximum index value, means index value on which the maximum value is present. Okay, dot item give me the score value. After that I have to round it to value, and after that, even after round it does not convert to int, I have to convert it in int. And after that, just pass the label and score. This all thing is over. Okay, it's too easy. I already explained each and every line in part one. If you if you want to know or want to know what why I'm using this and want to know more knowledge about it, you can see my part one. Okay, I explained it deeply in that. So where we main file. See, after that, pass the labels. One more I wanted to say that this C in this we have to pass. We are passing label and score if image in no multiple images there and no face detection is means face detection is detected. If suppose there is error in image, or we can say image is not on our conditions, this will throw process image the masses and the error on a score. Okay, on a score place. So in a, on a score, if suppose there is string error, we can say that there is a problem in a image. So so that to know the user, to make sure that user know what is the problem in your image, we have to display this whole thing. Standard or markdown, it will display the masses as a paragraph. That prediction, it will display the masses here, and this three things in a green color. Okay, and this all thing, this is a css only. Okay, you can know what is the meaning of this line, each and every line. I'm just displaying it using this st.markdown and save, and st.stop. Here streamlit will be stop, and message will be displayed here. This whole thing just to convert the image in this format, in the format that the Streamlit can display. We can easily display that image on a web. For ease of displaying the image on a web app, we have to use these three lines. Okay, after that, when image is ready, you have to use this standard.markdown, just display the image. Div here, image source, image base 64 means here, after converting the image in a format where that we can display it on a web app. Here predictions, what are the result? In result is a prediction, means on which class, and score basically give me the probability of that particular image. This way the whole Streamlit web app is ready. Okay, now let me run this. Let me run it. Streamlit run main.py file. I think it's throwing the error. Let me first create the virtual environment and install all the libraries which is required, so that it will not throw the error. Okay. Okay. See, it's creating. Let me activate this. Now my virtual environment is activated. Let me create one requirement.txt file so that I can download all my libraries which is required to run this streamlit.main.web app file. Okay. Okay. So these all are the libraries with the version names. Okay, done. Let me save it. Now let me code for downloading the requirements file. Pip store ISR requirement.txt. Press enter. So it takes time. I will pause this video and come back when all these libraries gets downloaded. Okay. So after downloading all the libraries, let me run my main file. Okay, what's the problem? Oh, no, STRE. Okay, it will open my web browser automatically. It's loading, so wait for the minute. So this is the interface of our web app. Let me choose one image of Ronaldo. Let's see how it's working. See prediction result to Cristiano Ronaldo. Probability is 100%. Let me select one other image. Uh, let me select this image. Neymar 98% means perfectly classifying. One more image of let's see this image. See, working well. Now we will see that our web app is displaying messages that if someone selecting multiple faces images or no face images. Let me choose this image. Okay, suppose multiple faces there in one image, it will display the message arrow. See, multiple face detected. Image should be having only one face and face should be clear. Okay. Let me choose this image where no face is there. It will display message again. See, it is playing. So our model is working perfectly. My Streamlit work is over. Now create a GitHub repository of this. Okay, of all this folder. Upload that this folder one by one and all the files. I will not do that thing in this video because it is a simple thing. But one thing is required is when you deploy the Streamlit web app, it is necessary that you have to give this requirement or txt file with all the libraries which you have to use in your in your project. Okay, so that you will not get stuck while deploying it. Okay, let me come back when I already created the GitHub repository for that. So this is a repository. I have uploaded all my files. This is a PPT which I have used at the part 1. Okay, so don't worry. And this is a requirements file which is necessary for the deployment with all the library which I have to use for the project. Okay, this is a model with the weights. Okay, PSMO model. All things is ready. So go to this website community cloud of Streamlit. Log in here. Okay, I already logged in, so I does not want to log in again. After login you will get the step interface. Just click on create app, deploy, select a repository. My repository is of football classification, so this is footballer classification. The file where your Streamlit code is there, just type it here, main which file which is the main.py file. Okay, if you want to change the URL you can change it, but I does not want to change it. Additional one more thing, that at advanced setting, just give the version name, Python version name which you are using. I am using 3.10. Okay, just save it and just deploy. It will automatically download all the libraries from the requirement.txt file and give you the link, so that you can share that link at everywhere, or you can use that link in your resume, so that you can see tell the in the interview you can describe your web project efficiently using the link only. Okay. Let's say it working or not. Okay. uh, After deployment, your link is ready. Just click on share, copy the link. I will open this in my Edge where there is nothing linked with my GitHub. Just paste it here. See, our link is ready and it's working perfectly. It's loading the web app. Wait a minute. See, let me cross check all the functionality which is working perfectly or not. Let me check for the Ronaldo. Perfectly working. And one more image of, let me choose other other player. Let me choose this one. Let's say displaying the masses or not. Multiple faces and no faces. Let's choose this one face, this one image. Displaying the masses. If suppose no face is detected, displaying. So our model is ready, our web app is ready, our model or project is ready, end-to-end project is ready. You can share this link everywhere. It's work perfectly. Okay, it's deployed. So thanks, thanks friends. Please comment, share, and subscribe. Please share my videos so that I will get motivated to work on this. The coming videos will be more good for you, for your resume. More project will be there, more details will be there, knowledge will be there. So please subscribe my channel. Thanks to all.